Alright, so next we're going to talk about average value, and make sure when we see this word value, this is not average rate of change. So, last unit we had average rate of change, which was for derivatives, okay, but this is not average rate of change. This is the average value of something. So the average rate of change was like, on average, what is the slope? How is it changing? It was kind of like we said this was algebra 1 slope, was the average rate of change. Okay, the average value is entirely different. So what the average value kind of tells us, if we're looking in between this A and this B on this interval, okay, all of our y values, the y values are normally what we say is the value of the graph, and the x values would just be like the locations, so during this period of time. So we have all of these different y values all along the graph, and if you kind of averaged every single one of them and you added them all up, now you can always get smaller and smaller, so it's kind of like adding up every single one and dividing by almost infinity, which you can't really do by hand, but eventually you'd get some value, maybe like somewhere here in the middle, but maybe that would be like our average y value, but that's like the average of all of those. And so this does have to do with an integral, and so the formula for average value, and it always has to be on some interval from a to b. Okay, you can't have an average without knowing where you start and stop. So our average value is 1 divided by b minus a times the integral from a to b of f of x dx. So basically we're just taking an integral and multiplying it by 1 over b minus a, or dividing it by b minus a. b is your upper endpoint, a is your lower endpoint. So as an example, if we were asked to find the average value of this function f of x equals 3x squared minus 2x on the interval from 1 to 4, we're just going to plug in our average value formula. So 1 divided by b minus a times the integral from a to b of f of x dx. So you don't have to write down the formula each time. You can just start by saying 1 divided by 4 minus 1 times the integral from 1 to 4, right? This first one will be a, the second one will be b. And then you'll just say of 3x squared minus 2x dx. And then here, this is where I said in one of the previous videos that if you want to do this all in one step, you can just say, okay, the integral of 3x squared would be 3x cubed divided by 3, minus the integral of 2x would be 2x squared divided by 2 from 1 to 4. Remember, we don't need plus c because it's a definite integral. Then you can simplify, and so we have basically 1/3 times x cubed minus x squared from 1 to 4. You're going to leave this 1/3 on the outside, and then we'll say we plug in 4. 4 cubed is 64, minus 4 squared is 16. Then we subtract. We plug in 1. 1 cubed is 1, minus 1 squared is 1. So again, what I kind of did is I skipped a step, but this was 4 cubed minus 4 squared minus 1 cubed minus 1 squared. And then from here we have 1/3 times 64 minus 16 gives us 48, minus, in this case, 1 minus 1 is just 0. And so 1/3 times 48 is 16. So the average value of this function here from 1 to 4 would be 16.